A single jet engine can cost more than one third of the aircraft itself. But its real value is not price. It determines whether a country truly controls its aviation industry. Today, only a few nations can independently produce top-tier larger commercial jet engines: United States, United Kingdom, France, Russia. Everyone else is still catching up. This is not politics. This is industrial reality. China has built a larger passenger jet. The C919 has entered the commercial service, but its core engine, the LEAP 1C, comes from a joint venture led by the GE Aerospace, suffering domestic engine programs such as the CJ1000A are still in long-term testing and scaling phase. This creates a simple reality. The aircraft can be domestic, but propulsion is not fully independent yet. If supply remains stable, operation continues smoothly. If supply becomes uncertain, the aircraft deliver maintenance circles, fleet expansion, or faces structural risk. Almost every industrial nation can build a jet engine prototype. The real question is, can you build one that the airlines trust for 30 years? The airlines do not buy engines based on national pride. They buy based on lifespan, reliability, fuel efficiency, maintenance cost, because engines determine the economics of aviation. The GE80 engine used on Boeing 777 designed a lifespan 30,000 to 50,000 flight hours. Some exceeded 60,000 hours. This equals 15 to 20 years of heavy operation. Many newer large engine programs globally are still progressing toward long cycles commercial durability. Even 2 times the lifespan difference means twice the replacement frequency, higher downtime, higher life cycle costs for airlines. One engine decision can impact the balance in operation cost. Modern engines like LEAP, 15% more fuel efficient than the previous generation. A long-haul aircraft burns roughly 20 to 40 million fuel per year. 1,700 Celsius temperatures, extreme pressure, continuous high-speed rotation for tens of thousands of hours. Leading manufacturers like GE and Rolls-Royce have spent decades developing multiple generations of single crystal superalloys. Each new material generation requires 10 to 20 years of testing, hundreds of thousands of testing hours, roof light validation, long-term fatigue data. This cannot be rushed. It can only be accumulated. Developing a new large jet engine, typical timeline 20 to 30 years, typical investment 20 to 40 billion. GE has invested hundreds of billions across multiple engine generations over decades. This is not a single product race, it is a century long industry marathon. A global commercial engine market is dominated by GE Aerospace, Rolls-Royce, Pratt, Whitney, Safran. These companies control the majority of large commercial engine supply. Breaking into this market means challenging 80 years of accumulated engine data, global maintenance networks the airline trust built over decades. This is not just a manufacturing, this is an ecosystem dominance. The aviation engines drive high temperature materials, precision manufacturing, advanced coatings, control systems, high-end machine tools. The engine industry sits at the top of the industrial pyramid. Whoever masters it pushes forward their entire manufacturing system. If a nation can build an aircraft but not fully control engines, where does the real control sit? If supply chains remain stable, this question stays theoretical. If they do not, it becomes immediate. This is not alarmism. It is a basic industrial logic. Navigation engines are not just mechanical products, they are one of the highest barriers in modern industrial civilization. Only a few nations have crossed it. The rest are still climbing, not because they lack ambitions, but because this climb takes decades and cannot be accelerated by intention alone.